morning to one and all. My name is Krishna Mohan, working as an assistant professor in Computer Science Department, AIML. Today we are going to see Unit 4, a basic processing unit from the syllabus or from the concepts of computer system architecture. So here we are going to see what are the device components for developing hardware control unit and microprogrammed control unit. First, we will see what are the list of concepts we are going to discuss in basic processing unit. We will see hardware control unit. After that, we will go for microprogrammed control unit. Then we will discuss the detailed structure of memory hierarchy or memory system, where we are going to see the memory hierarchy. After that, we will see secondary memory, cache memory, virtual memory, and memory hardware control unit. So all these are going to be discussed in memory hierarchy. And before that, before going to the memory hierarchy, we will see what is hardwired control unit and what is microprogrammed control unit. So design of control unit is categorized into two types. One is hardwired control unit and another one is microprogrammed control unit. Suppose if you want to process an instruction, the processing of instruction is categorized into two types. One is hardwired and another one is microprogrammed. So how we process the instruction in hardwired control unit? First we will see that. After that we will discuss how the instructions are processed in microprogrammed control unit. Right. So the hardwired control unit is a control unit that is used to fix the set of logic gates for the circuits. Basing on these circuits, the circuits are controlled by using the wires, where these wires will try to establish a link between all the logic gates and execute the instruction or execute the input what we are going to give. So how these are integrated with one another and how the instructions are carried out and how the instructions are executed from one to one will be carried out in the hardware control unit. The hardware control unit can be viewed as a state machine which changes from one position to another position. Suppose if I am giving an instruction with less number of bytes or bits and the instruction is executed. Once if the instruction is executed and processed, immediately I should go for the next instruction. If the memory of the instruction is more, if the instruction what we are given in the second level, the size of the instruction is more, then immediately we have to change the circuit or the instruction capacity or the memory capacity, where we should try to improvise or where we should try to improve the efficiency or the speed of the instruction execution. See, the sequence of operations are carried out by this machine, which is determined by wiring the logic gates, because the wired logic circuits are going to play a very important role in hardware control unit, because these circuits are connected with the concept of wires. So this is called as a hardwired control unit. Hardwired because these logic gates or logic circuits are connected through hardwires. Next, the fixed logic circuits that corresponds directly to the Boolean expressions are used to generate the control signals. The control signals plays a very important role while executing the instruction. The state of the machine is going to be indicated only by the control signals, because the control signal indicates ones and zeros, where if it is indicating 1, it resembles the instruction is going to be executed, and once if the state machine is indicated with 1, it can be considered as the instruction process. Once if I compare the hardware control unit with microprogrammed control unit, these two control units are used for executing the instructions. Once if this hardware control unit is used and I compare this hardware control unit with microprogrammed control unit, so what is the benefit I am going to get? So is there any benefit if I use this hardware control unit? Yes, hardware control unit process the instructions very fastly when I compare with the microprogrammed control unit. Next, the controller that uses this approach can operate the high speed. So this processing of the instruction by using hardware control unit can be considered as the fastest way of executing the instructions. So RISC architecture is based on hardware control unit. RISC and CISC are the two architectures which we use for the execution of the instructions in the digital computers. So coming to the hardware control unit uses CISC architecture, RISC architecture, where it is working completely based on the architecture of this particular component. Next, if you see here, we will see the basic architectural diagram, where this architectural diagram interacts with all the components which are incorporated in this diagram and process the instruction which is given by the user, and it gives the output. If you see the diagram, we will see two decoders. We are seeing, one is 3x8 decoder and the another one we are going to see here is a 4x16 decoder. These two decoders play a very important role while executing the instructions by using hardware control. Immediately all the instructions are controlled by the bit sequence counter, where it increments whenever the instruction is executed. It increments the counter as C is equal to C plus 1. Once if the instruction 1 is executed, immediately the instruction 2 has to be executed. The sequence counter plays a very important role for the execution of the instructions. All the instructions which are given by this particular hardware control block diagram has an instruction register, where this instruction register carries 16 bits, where the 16 bits are the memory occupation will be from 0 to 11, and after that 12, 13 and 14 are carried out for the opcode. So 12, 13 and 14 bits are going to be occupied by the opcode, where the operation codes are specified, in this particular 13 and 14. And coming to the 15, it is going to be the control of the logic gates. All these are connected. The instruction register, the decoders which two we are using, and the 4 sequence counter. All these instruction registers and decoders are connected to the logic gates in the form of inputs, where the control logic gate will try to process whatever the instructions which are given by the instruction register, and it is going to give the output. Coming to the next slide, if you see, we will try to see how the hardware control unit is going to work. So in the previous slide, if you see, we will try to see the complete components or the complete registers and the decoders which we are using. Here we will try to discuss how these all are integrated and transferred the instructions or transfer the input to the control logic. Right, if you go to the working of hardware control unit, the basic data for control signal creation is contained in the operation code of an instruction. See, the basic data of control signal. Is controlled by opcode. Suppose if you go to the instruction register, we have discussed here that 12, 13 and 14 bits are used for opcode. So the opcode is going to create the control signals, where these control signals are generated by using the opcode. Next, the opcode is decoded in the instruction decoder. So this opcode is decoded in the instruction register. Next, the instruction decoder is a collection of decoders that decode various fields of instruction opcode. Right. Next, the hardware control consists of 2 decoders. So as we discussed, here we find a 3x8 decoder, and next if we go, we find 4x16 decoder. So these 2 decoders are linked to sequence counter. The sequence counter and the number of logic gates. So these 2 decoders connected with the help of the sequence counter, where the instructions are repeatedly executed, or if the instruction is completed 1, immediately the instruction 2 has to be processed. So the instruction 2 has to be processed, the sequence counter has to come into the picture, where the sequence counter gives the increment of all the registers. Next, The component of the instruction register includes one bit, the operation code, and the bits through 0 to 11. The 0 to 11 occupies the memory occupation, where all the instructions which are given as an input is to be carried out by the 0 to 11 and decode 0 to 11 instructions. See, the operation code in bits 12 through 14 are coded with a 3 by 8 decoder. The opcode is linked with a 3 by 8 decoder. The opcode which is linked with 3 by 8 decoder is going to be decoded as 3 by 8 decoder. Immediately, the output of the decoders are designated by the symbols D0 to D7. The output of the decoder, suppose if I take it as 3 by 8 decoder, the output will be from D0 to D7, means 8 bits. 3 inputs we are going to give, and the symbols which are indicated or the symbols which are designated with D0 to D7 are considered as the controlled signals. Next, the operation code of a bit 15 is transferred to the flip-flop generated by the symbol S. See, the operation code 15 is transferred to flip-flop, that is the last bit. If you see this, the 15, it is a basic processing unit or the hardware control unit block diagram, where this I is considered as the flip-flop which is indicated by the symbol. Flip-flop carries out the operation codes with 1 and 0. See, the operation code bits from 0 to 11 are applied to the control logic gates. Because it carries memory 0 to 11, these all are linked to the control logic gates as the form of the input. The sequence counter can count in the binary form through 0 to 15 because the instruction register carries 0 to 16 bits, or it carries 16-bit register. The 16 register bit is indicated or it is counted with a sequence count. So in this way, the hardware control unit is processed and it is going to execute the instructions. Whenever required, we have to change the hardware logic gates depending upon the instruction what we are giving. Next, coming to the second device or the second component for execution of the instruction, we are considering it as micro-programmed control unit. In short form, we will call it as MCU, micro-programmed control unit. So coming to the micro-programmed control unit, it stores the binary control values as in the form of words. Here we do not use any type of hardware systems or hardwired logics or hardwired controls to control or to execute the application. Whatever we are going to do in the micro-programmed control unit is done only through the programming only. So if I say it as the micro-programmed control unit which stores the binary control values as control words. Here if you see, the words in the memory are used for programming approach and the micro operations. The next, the microcontrol memory stores microprograms made up of micro instructions, where the MCU's control memory stores, because MCU, if it has to execute an instruction, it stores the microprogram. Initially, it has to store the program. Once if the program is stored in the memory, then it can be transferred for the execution, or it can be transferred to the ALU. So in this way, the microprogram is generating specific signals. It generates the signals in the form of control signals, where these control signals will monitor or will transfer the instructions from memory unit to the ALU. And once if the ALU operates the instructions, or once if the ALU executes the instructions, immediately the instructions output is transferred to the output or in the form of a monitor. The main difference between microprogrammed structures and hardware control unit is existence of the control store. The main difference, if you see, between microprogrammed structure and hardware control unit structure is the existence of control state. The control state has to be existed when we execute the hardware control unit or when we execute the microprogrammed control unit. Hardware control units are usually faster than microprogrammed design. So as we told, hardware control unit plays a very important role for the speedy execution of the instructions. when we compare that with the microprogrammed instructions. Like hardware control units use state counter and PLA circuit. It uses majorly state counters and PLA circuits to generate all the control signals needed inside the CPU. So whatever instructions which are to be handed out by the CPU, these two, that is the state counter and the PLA circuit, plays a very critical role for the CPU which is to be executed in the hardware. Next, if you see here, we'll try to see the basic architecture diagram or the basic block diagram of the microprogrammed control unit. See, in the microprogrammed control unit, first we see the next address generator or generator sequence. Means whenever an instruction is going to be executed in some address, that is 1023. So once if 1023 memory executes an instruction, immediately the next instruction has to occupy the address of 1024. So that sequence of memory generation, that sequence of next instruction generation is carried out by next address. Immediately the address which is generated or the address which is stored will be transferred to the control address register. In the short form, we will call it as CAR. CAR is considered as control address register, where all the addresses of the registers, are stored, and whenever the CPU or the ALU has to execute an instruction, immediately the control is the signal is generated, where the signal transfers the information from one location to another location. Once if it is transferred, immediately the control address register transfers it to the control memory, where the control memory stores all the instructions which are to be executed, and it transfers to control data register, where this control data register is called as a control word, where this control word consists of the memory locations. Along with the memory locations, it has some basic instructions also to be stored in the control word. So control word, whenever it gets a control signal, immediately it hands over the instructions to the ALU to execute the instructions and transfer the output to the output units. Now we'll see the characteristics of microprogrammed control unit. So if we compare the microprogrammed control unit with hardware, it differs, because the microprogrammed control unit is totally controlled by the basic instructions or the basic programs what we are writing. There we will not use or we will not make any type of writing the code. Simply we try to make the use of the control logic gates or the wired controls which are managed by the CPU. First characteristic, the micro instruction address is specified in the control memory address. The micro instruction address, the instruction which is to be executed, it has some address. It should have some address where the data is stored in this particular address. So all the control information is saved in the control memory. The control memory stores all the information, because whenever an input is going to give some information, first before going to the ALU or before going to the processing, it has to be stored in the memory. So that memory is considered as control memory. First, initially, all the instructions will be stored in the control memory, which is considered to be as ROM. So that control memory, we are going to call it as ROM. Next, the micro instructions received from the memory is stored in the control register. Control register stores all the micro instructions which are received. Once if these are received here, the signals are generated to transfer the information from the control board or the control memory to the execution or the processing of the instructions. Next. So in this way, the microprogrammed control unit is working when we compare that with the hardware control unit. So as we compared, the microprogram plays a slow execution, or when the instructions are processed in the microprogrammed, it is very slow when I compare that with the hardware control unit. So next we move on to memory hierarchy. So how the memory is stored and what are the different types of memories we have in the computer system to be stored and to be transferred or to store the locations with some particular memory addresses. See, memory hierarchy is one of the most required thing in the control memory, because without a memory in a computer, we cannot process any type of instructions. We cannot process any type of instructions where these instructions has to be stored in the memory first, and from memory instructions has to be processed. So it helps in optimizing the memory available in the computer. There are multiple levels present in the memory. So if I say it as a memory, it has different types of levels where each level has its own importance. See, if we go to the diagram of memory hierarchy, initially we will consider this as level 0. So first, if you see the diagram, we are going to see here as level 0. So what the level 0 will do? The level 0 will have the registers. No doubt registers also store the information, but less memory is stored in the registers, where the processor will try to attack the register first and execute the instructions which are located in the registers. So level 0 is considered as the speed of the execution of the instructions which are located in the registers. Next, if we see to the level 1, we are going to see the cache memory. Static RAMs we are going to see here. How the static RAMs are worked, we'll discuss later when we go to the cache memory. Immediately, if we go to the level 2 occupies the main memory. This is a very critical memory where all the data which is to be stored will be in the main memory, and these memory uses DRAMs to store the information. So this detailed discussion we'll do when we go to the main memory. Coming to the level 3, we'll see the magnetic disks, storage capacity, the floppy disk or the disk drives or the hardware components. Right now, what we are using in the latest technologies, all these are coming out to disk storage or the magnetic storage. The level 4 is the optical disk, and finally the level 5 is the magnetic tapes. So all these are the different types of levels of memory hierarchies where we have each one has its own importance when we go to the levels, and we'll discuss. So finally, the memory hierarchy is categorized into 2 types. So once if the categorization is done, then we'll discuss how this each categorization and how the category is done and what are the different levels we have in each category. So first we'll try to see how the external memory and how the internal memory is categorized. So memory hierarchy can be categorized into 2 types. One is the external memory and another one is the internal memory. External memory is also called as secondary memory. The other name for the external memory is the secondary memory. So comprising of magnetic disk, optical disk, magnetic tapes, and all different types of storages what we do from the external sources. So from the external sources, whatever we are going to insert into the CPU and storing the information or storing the data is going to be considered as the external memory or the secondary memory. Next, when we go to the internal memory or the primary memory, so which consists of the main memory, cache memory, and the registers. So basically, the processor will try to look into this particular memory where it has to execute the instructions. Once if the processor has to execute the instructions, and if it control is transferred, and if the control of the processor is transferred, first the transfer will be to the registers. So it sees into the registers. If any instructions are there in the register, executes that, then it will go to the main memory and see that if any instructions are there in the main memory to be executed. Right? So this is directly accessible by the processor. So processor first it doesn't go to the external memory or the secondary memory. Basically it try to check in the internal memory or the primary memory. This primary memory plays a very important role for the memory hierarchy because the processor is going to check the main memory first and then it is going to the secondary memory, because main memory consists of the registers. So this CPU and registers and cache memory. So these are all the main memory parts which the processor has to see and it has to execute the instructions. So these two are the basic memories where the memory hierarchy is going to be carried out. So we have seen how this basic processing and what are the different types of memories and at different levels it has been categorized. So now we have to say that these type of memories should come under the external memory or should be under the main memory. Right. Coming to the memory hierarchy, first we will see the concept of registers. So as I told you, the registers comes under primary memory. So how these registers are organized and how the registers are accessed by the processor. So registers are small high-speed memory units located in the CPU. So CPU consists of main memory and registers. So both these are considered as the storage of memory or the storage of information. But when the processor comes into the CPU or when the processor has to execute the instructions, initially it checks if any registers are there or if any data is there to be executed in the registers. So they are used to store the more frequently used data in the instructions. So if frequently executed instructions are there, those instructions are to be stored in the registers, not in the main memory. Why? Because whenever we are going to store the instructions in the main memory, the processor has to repeatedly check the addresses and it has to take much time to execute that instructions. So if such instructions are placed in the registers are very faster when you compare with the main memory execution. So the registers are going to be the fastest access time when I compare them with the main memory. Like that, if we go to see what is cache memory. So this is also a very small memory like which we have in the registers. So main memory has a huge capacity to store the information, but the registers has a small and high speed memory. It is small, but the speed of the execution of the instruction in the register is very high. But if you go to the cache memory, it is small, but it is fast. So cache memory also, it is going to occupy the less number of instructions when we compare that with the main memory. Coming to the main memory is known as RAM, random access memory. So this random access memory is under primary memory. So under the main memory, we can find the registers and we can find the cache memory and finally the main memory, because the processor first checks into the registers. Once if the registers are completed, immediately it goes to the cache memory. If any instructions are there in the cache memory, it tries to execute the instructions in the cache memory and then directly it will come to the main memory. So how this main memory is executed? Because main memory has a huge capacity storage when we compare that with the registers and the cache memory. So main memory has the huge memory and the processor, when it is going into the main memory, it takes more time for the execution or to find out the instruction when we compare that with the cache memories and the registers. Right. So the types of main memory are two types. One is static and another one is dynamic. So if you see the difference between the static and the dynamic, static RAM stores the binary memory in the flip-flops. Static memory stores the binary information in the flip-flops. Right? And the information remains in these flip-flops till the power is on. So whatever information we are going to store in the flip-flops, that remains till your power or till the computer is switched off. So it has faster access time and is used for implementing the cache memory. When we go to the dynamic RAM or dynamic memory, it stores the binary information as the charge on the capacitors. So if you compare that with the static memory, it stores the binary information as a charge on the capacitors because it requires refreshing circuit to maintain the charge and the capacity, because the charging is very important when we compare this dynamic with the static, because the static, when the power is off, it is not going to repeat or it is not going to make the information which is stored previously, so it will be zero and again freshly we have to give the information to the instructions which are given in the static RAM. So it contains more memory cells per unit as compared with the SRAM, because the dynamic memory is going to store the large information with much time. So what is the thing required here is the memory cells per unit area are more when we compare this DRAM with the static RAM. So these will be considered as the memories which are coming under the internal memory or main memory. See, we have seen what is the main memory, and we have seen the concept of the registers, how the registers are executed, and we have seen the cache memory. So parallelly, registers and cache memories are one and the same when we compare that with the main memories. So next we will see how the external memory is used and how the categories are measured in the external memory. Thank you.